Good morning, everyone. Okay, so just for a quick reminder, in our next lecture session, we will be having the exam. So that was already been announced in the last week. So just keep the note of it and be prepared with the exam. So I guess tomorrow is the only lecture. So we will be having a exam tomorrow. The exam will be having the questions regarding the graphical method, simplex method, and big M method. Fine. So let's start with our new concept of integer linear programming, and that is the last concept of this particular module. So let's start the discussion of it. Integer linear programming. I hope the whiteboard screen will be visible to you all.
Yes, sir, visible.
Okay. So can anybody just tell me what are the issues that can be faced with the type of the approach that we have adopted till now in obtaining the solution? What are the issues that can be faced? Okay, I have got some of the answers that complexity, then long process to get solution, time consuming process, more resources are used in order to have the extra surplus variables. Okay, fine. All are the correct answers, but what major drawback this particular method is having? What is the major drawback? Other drawback. The drawbacks that you have told, you probably four people have told, are the drawbacks corresponding to, I can say, resource based drawbacks. I am asking for logical based drawbacks or the method based drawbacks. What are the probable drawbacks of this particular method? Anybody? One of the major drawback is that you are always trying to find the solution for your decision variables. The solution for the decision variables, and these decision variables are nothing but, let's say, x1, x2, x3 up to, let's say, xn. Whatever features you are having, you would be comprising one decision variable corresponding to each of them. Now, over here, you are having, these are all the decision variables. You are trying to find the solution for all these decision variables. Now, this particular decision variables may be something like liters of milk, for example, man hour, or you can say something like number of units, or you can say units of machines, etc. You can say anything. Depending on your question, depending on your problem statement, you can say these things. But what if I say number of units to be equal to 2.54? What do I mean with this? Let's say the labor is the number of people required for any particular process is, let's say, 3.2 or let's say 3.5. What do I mean by this fractional part or the decimal part? 3.5 means what? What can I say? That I would be asking three people to work with two hands and I would be asking one person to work with only one hand. Is it so? Do I mean by that? No, no, absolutely not. Then what I will be saying that, okay, using this particular limit, I would be saying that, okay, there are three people who would be required. This 3.5 can be approximated to 3 also, it can be approximated to 4 also, depending on the maximization or the minimization, or depending on the constraint, you can just do the approximation. You need to keep the thing in mind that, okay, this is the particular constraint, and because of that particular constraint, I need to just mold my answer to 3 or 4. So the methods that we have looked into till now doesn't look into the answer of the integer values. They don't look into the integer solutions. They just look for the optimal solutions. Now we don't consider whether your solution that you have obtained is an integer or not. It don't consider that. So that is the drawback of that particular methods that we have seen. You can take the example of graphical method, you can take the example of simplex method or big M method, any method you just take up. There is a drawback that it don't look into the consideration of your specific decision variables. Whether the decision variables are intending to find some integer type of values or not. So for that, we would be adopting two methods. There are two methods in order to find that. First is the exhaustive search. Exhaustive search. And second is the branch and bound. This method we have been familiar with. Second is branch and bound. So let's start the discussion of the exhaustive search. Now, exhaustive search is the same method that we are having in the graphical method. So I would be doing right now this first method, that is the exhaustive search, because it will also give you the practice of the graphical method. Fine. So let me write the question directly. Your question is to maximize the objective function, and it's this one, 5x1 plus 6x2. The constraints that you are having are x1 plus x2 less or equal to 5. 4x1 plus 7x2 less or equal to 28. X1, x2 greater or equal to 0. And one more thing that will be added is x1, x2 are integers. So everybody just make the graph for the two constraints. Quickly make the graph for the two constraints, and then we will be discussing this. Quickly make the graph for these two constraints. I am giving you 2 minutes to make the graph for these two constraints. Quickly make it. Okay, let's start doing the graph plotting. This is the graph that I already plotted. Okay, I hope the graph will be visible to you all. This is the one of the same example. Now I won't be wasting the time or investing the time rather. It's not the wasted, but it's the investing of the time for drawing of this particular graph. Okay, so these are the two constraints that we are having. The first constraint is nothing but the x1 plus x2 is less or equal to 5. So this is the first constraint. And the second constraint is nothing but for x1 plus 7x2 is less or equal to 28. So this is the first constraint. This is the second constraint. Now I want the points. I want the points corresponding to all the things. That is the corner points. This is nothing but 0, comma 0. This is 5, comma 0. This is 7, comma 0. This point I require. This is 0, comma 5. And this particular point is 0, comma 4. What is this particular point? I received answer from one person. Okay, can you just tell me what is that point? This particular point, is it 3 comma 2? Just verify. See, don't approximate to the integer value. We are learning that thing how to approximate. We directly cannot approximate it. There are certain reasons behind it. Okay, 2.33 and 2.66. Let me write it 2.33 and 2.66. I hope it will be the correct. So let me write 2.33 and 2.66. I don't know whether it will be the inverse case or the same case 2.33 and 2.66. From the graph, I can say it should be inverse case. I don't know. So I can write 2.33 as 7 by 3 into 4 plus 2.66 is 8 by 3 into 7. So what will be the thing? 28 plus 56 by 3, 84 by 3. Fine. Okay. So let's say these are our points. These are our points. Now, if you can just look forward for all these points, which is the point which is giving you the maximum answer? Which is the point that is giving you the maximum answer? Can anybody just tell me? The same concept is that we have discussed in the graphical method. I want the solution same as the graphical method. We are not doing anything new. These are all the corner points. This is the feasible region. This is the feasible region. Okay, 3,2. Fine. Okay, we are having, I just told, again I'm repeating, don't move directly into the integer linear programming. I am having same as the graphical method. We are having 0, 4 as one point, 0, 0 is the another point, 2.33, 2.66 is the another point, 5, 0 is the another point. These are the 4 points which we are having. Okay, we are having the maximum answer at this particular point, that is 2.33 and 2.66. Fine. So this is what is been expected from the graphical method. But since you can just see that in the graphical method, we are having this particular solution which is not integer, which is not integer. So what should be our next step? So the next step is that we are doing the exhaustive search. Exhaustive search. So as the name suggests, it's the searching. How we are searching? We are exhaustively searching. Exhaustively means to search for the points till it gets exhausted. So just put a dot. This is the nothing but our feasible region. I would be highlighting it using the green. Let's say this is our feasible region. This is our feasible region. Now, from the entire feasible region, just pick out all the points that are integers. Pick up all the points that are integers. So let's say this is the integer point. I'm just doing it with the green. This is the integer point. This is the integer point. This is the integer point. This one is the integer point. And this one is also the integer point. This particular intersection is above this point. Again, this are the integer points. This is the integer point. These are all the integer points. So the points which I have highlighted in green are all the integer points, are all the integer points that are lying in this feasible region. So it's obvious that our answer will be one of the point which is marked in the green. I am repeating, our answer will be one of the point which is marked with the green because our x1 and x2 are the integers. So what we need to do, the main thing that is required to be done is to find the solution for all these integer points. To find the solution for all these integer points. Now you will be saying that this is as of now we are having 4 and 4, 8, 11, 14, 16, 17. 17 integer points. But there are the chance that we may have, for example, 50, 55, 60 integer points, depending on the feasible region. Depending on the size of the feasible region, we may have too many integer points. Then, should we be doing the calculation for all the integer points? Should we be doing the calculation for all the integer points? Can anybody just tell your opinion? What could be the better solution? If I know that, okay, one of the green point will be the integer point, then should I be considering all the integer points or should I be focusing on the few set of the points? And why? Okay, answer is no. That's correct. That we shouldn't be focusing on all the integer points. But why? Then which type of the points should I be focusing?
Sir, according to me, we should focus on the points which are lying near to that feasible line region, like the blue and orange line.
Okay, we should be focusing on the points which are lying blue near the blue and the orange. Fine. Viraj has to say that maximum bounding points having the higher values that are integers, correct? Okay, Deepesh also has to say that we have to focus the points near to the original fractional point, correct? Akshat has to say near to 2.33, 2.66 is it is the maximum point. Okay. Okay, fine. So all the answers that you are saying is correct. All the answers that you are saying is correct. But I want the answer that will be defining this your correctness. You told that okay, the point should be considered which are lying to blue and orange. But why? And that will be the answer. Your answer is correct that we will be considering all the points that are lying near the blue and the orange lines. Or we would be considering the point which are lying near the maximum point that we have obtained. But why? Why not other points? Any another reason? If you can just give, then it will be a good answer.
Sir, I think like since we are trying to maximize the solution and the points closer to the lines can be considered as the maximum. Above that, you cannot cross your feasible region. So that's why I think we are taking those points.
Okay, partially correct. I would be saying that 65 to 70% correct. Right. Karan has given a very right answer that we would be maximizing it. And I was looking for this particular word, that area covered under that point. I was looking for this particular word, and that was the reason I was asking everyone. It's the area covered under that point. The reason is the area covered under the point. The concept is right, but this is more technical word, area covered. So you can just see that, okay, as and when we move from left to right, suppose I'm moving from left to right or from bottom to top, my values are going to get increased. My value specifically of z, that is nothing but my objective function. My values specifically for the objective functions are going to get increased. So if I consider this particular point and this particular point, definitely my value at this particular point would be higher. Same thing, if I consider 0, 0 and 0, comma 1, then this particular point will be higher than 0, 0. So what you can see that more and more you move to the right side and more you move to the top side, your area that will be covered under that point will be broadened enough. It will get broadened enough. So that will be giving you more output. That will be giving you more better answer. So if you can just see this particular point 0, 0, then there is the area which is 0 that will be covered. If you can see this particular point 0, 1, then it will be only one strip that will be covered. If you can see the particular point 1, 0, then it will be nothing but the horizontal strip that will be covered. Again, continuing with this discussion, if you can see this particular points, for example, 1, 1, then the entire this square box, the area covered by this square box will be considered. If you can consider this particular point, that is 2, 1, then the area covered by this two boxes will be considered. So you can see that the area that is being covered is getting increased as and when we move from left to right or from bottom to top. So that is the reason we would be looking for the maximum covering area point. So suppose I am looking forward for the points that are lying near this particular range or near this particular two lines, then this is the first point. Then another point that is lying closer to that is this one is the second point. This one is the third point. This one is the fourth point. And this is the point that is on the line. Now just draw the area coverage. So for that, you will be drawing this particular strip if you are considering the first point. The rectangular slide strip that I have considered will be the first strip. Calculate the area for it. Calculate the area for this first strip. Okay. Second thing, if you are considering this second point, then calculate the area for this particular strip. Again, if you are considering this third point, then calculate the area for this particular strip, this particular box. The area for this particular box. If you are considering the fourth point, then again the same process. Calculate the area for this particular block. Then you will be realizing that okay, the area for let's say this particular point will be maximum. So should we be considering the area for all these points? Then again, you should be considering only the points which are lying at the maximum extremities near to the constraints. So consider this point. This will be the 0th point. So I will be writing which are the points that you need to consider. If even though you know the answer, you need to show this process. That okay, I have found out this particular points, but since the maximum point that is maximum answer that is being obtained is the non-integer answer. So for that, I will be considering the points that are lying near to the constraints. And these are all the points that we are nothing but 0, 4, then it's nothing but 1, 3, then the another point is let's say 3, 2, then another point is 4, 1, and another point is 5, 0. So you will be probably realizing why I have considered these 5 points. There is the first point 0, 4, then there is the second point that is nothing but 1, 3, then this is the third point that I am considering that is 3, 2, the fourth point that is nothing but 4, 1, and the fifth point is the 5, 0. Instead of calculating for all the 17 points, you will be calculating only for the 5 points. And you will be obtaining the objective function output for all these 5 points. And with reference to these 5 points, you will be saying that, okay, this is the best answer. So just put the values for all these 5 points. So our equation is 5x1 plus 6x2. So let me just put the values 5x1 plus 6x2. So this will be 24. This will be 5 plus 18, 23. This will be 15 plus 12. So 27. This will be 20 plus 6, 26. And this will be 25. So you can see that this is the particular value which is giving you the maximum answer. So after this, you can say that, okay, my answer is 3, 2, which is giving me the value of 27, and both x1 and x2 are integers. You directly cannot say that, okay, I will be considering these points. Why? Because you don't know. Even though there is the simple question, so you can directly recollect that, okay, which is the particular answer. But in the complex type of the questions where there are multiple area coverage, you cannot certainly say that, okay, there is a particular answer. You can just roughly estimate. It may or may not be the correct answer, but you can roughly estimate, just as what we did. That we would be giving the justification that, okay, as and when I move from left to right, or I move from bottom to top, my values of objective function gets increased because the area coverage under that particular considered point is higher. As a result, I will be considering the points which are lying very closer to my constraint lines. So these are all the 5 points which are lying to my constraint lines, near to my constraint lines. And so I will be calculating the output objective function values for those particular 5 points. Okay, Prerna is a very good question that why we cannot just get answers in ratio and then rounding it in integer. Okay, that's also a way, then why not that? Fine. So in the complex problems, just rounding it to the values, you may or may not get the correct answer. Suppose you are having in this particular case only, let's take this particular values. 2.33 and 2.66. You know that, okay, this is the maximum value that you can obtain. So you just round it to the value, the concept with which we have learnt. You just round it to the value. So it will be nothing but 2.3. Now, this particular value 2.3 will be there is one of the answers. 2.3 will be there as one of the answers. The same thing that we have learnt. The rounding function 2.33 and 2.67, we have learned that, okay, if the values are less than 0.5, then we will be rounding to the closure value or the bottom value, the floor value. And if it is greater or equal to 2.5, then we will be rounding to the ceiling value. But there are the chance that by doing that particular thing, you are moving either outside the boundary or you may not get the correct answer. If you are putting this 2.3, then you will be getting the answer as 18 plus 10. So it will be 28. You are getting the higher answer. But where is 2.3? Just check it. Where is 2.3? Whether it is obtaining within the solution. It's moving outside the solution. See, 2.3. This particular point over here. That is outside the solution or outside the feasible region. So if you are considering the bottom part, if you are saying that, okay, by rounding it to the top one or the ceiling one, if you are rounding to the floor ones only, if you are saying that, okay, by rounding to the floor ones only, I may get the correct answer, then it will be 2.2. Then 2.2, whether it is there in the feasible region, it's there in the feasible region. But what the issue will be, if you just calculate the values, it will be 12 plus 10, so 22, which is less than 27 that we obtain. So that is the reason we may not get the assurance that, okay, by rounding to the upper or the bottom part, we may not get the assurance that our answer is correct or not. Okay, any further questions, anybody? Anybody having any other doubt? Please clarify your doubt if you are having, because this is a very simple method. So we may not be doing extensive examples for these methods. I am giving you all 1 minute to just look into the entire method again. And if you are having any doubt, then you can ask. Okay, fine. So for the practice, let's have one more example, and I hope you can now easily do it within 10 more minutes. So start doing this particular question. Very simple. That particular question should be completed in 3 to 4 minutes because you would have realized that it's already the integer based linear programming question only. The answer that you are obtaining is directly the integer. So, what was the purpose of giving that particular question? The only purpose was that it's not at all necessary that if you have been asked to solve the integer programming question, then you should be having the non-integer value only. You may get x1 and x2 to be such a values that are integers. So you can directly write that, okay, since the value that I obtained is the integer, I am directly obtaining the value as our final answer. After that, solve this next one. Your answer could be 0, 2 if I'm not wrong. And your maximization value will be 2. Okay. So just start doing the second question, second part. So that was the reason I told that you first obtain the solution using the graphical method, because there are the chance that in the graphical method also you may get the correct answer in the form of the integers. If you are not getting the answer in the form of the integers, then only you can switch to this. Okay, I have received one answer 1,3 with solution 11. 1,3 with solution 11. If anybody can just confirm the answer. Okay, two answers with 1,3. In this particular exam class test that I will be taking, this integer linear programming won't be there, but in your midsems, it will be there. So I would be expecting the full descriptive answer, the reasonable answer, the answers with the reasons. If you are not writing the complete detailed reason for the answer, you may not get the full marks. Fine. So I have obtained the particular answer from 3 people, and so I assume that it will be correct. So these 2 questions you should be trying to complete as a part of your homework if you are not done. And you can just write your roll number and name for your attendance, and you can join for the next lecture. But make sure that tomorrow you come with your notebook and pen with the scale to attempt the questions of the class test. Fine, that's it for today's session. Thank you.
Sir,
Yes. हाँ प्रेरणा.
uh,
Yes.
sir, actually, I was saying for this type of question, you solve one question and give, because if you are saying like in mid, we have to write it in step wise and with reasons. So how to write means I don't know means much. So if you
Okay.
solve one and give, then it will be more clear.
Okay. So the same reason that I have just mentioned or dictated, I will be just writing the reason in the next session. Whenever we'll be discussing the next type of the approach for integer linear programming, I'll be solving this particular question also. Don't worry about that.
Sir, it means I'm saying like how to write in question paper. I want to know that only. Means what is the steps we need to write it in.
Okay, fine. So I'll be just sending the solution for this type of the question. I will be also uploading it in Canvas. Now, just remind me by Saturday to do that thing.
Okay, sir. Thank you, sir.
Okay.